All right, Matthew. Going into a different topic today. We're going to start talking about trig, the three trig ratios: sine, cosine, tangent. Um, I want to go over a couple things before we start getting any problems or whatever. Let's see. Got a new pencil. Don't want to write exactly the way I want to. Trig. All right, trigonometry. Okay. Now, let's see. All right. So we're gonna go into trigonometry. All right. Let's see. Let's get some basic stuff down. Okay. Trigonometry is the study of triangles. That's what trigonometry is. It's the study of triangles. Um, now, there's three. There's three ratios that are used in trigonometry. Well, there's more than this, but the most basic ones are sine, cosine, and tangent. Okay. Now, long ago, these were set. Uh, Mathematicians noticed no matter if you had a right triangle, um, no matter how long one of the sides got, or no matter how big the triangle got, that there was always this common ratio between the sides. Okay, and that's where your sine, cosine, and tangent ratios come from. Okay, now sine, um, it deals with the opposite side and the hypotenuse. Okay, the cosine deals with the adjacent side and the hypotenuse. Okay, not too good at drop writing this morning. Hypotenuse, and then tan deals with the opposite side and the adjacent side. It always deals with these ratios. Okay, the ratio of the opposite over the hypotenuse. The cosine deals with the adjacent over the hypotenuse. Tangent deals with the opposite side over the adjacent side. All right, now a couple things you need to know. It's got to be a right triangle. Okay, has to be a right triangle. Okay, so right triangle means that you got a 90-degree angle in here. All right, you got a right angle in here. All right, okay, and now let's now you'll hear me mention theta. Okay, theta is a Greek letter. Okay, and it always represents a missing angle measure. All right, it represents a missing angle measure. Okay, now so say if theta is here, theta is here. Okay, that's the angle in question. Okay, you're you got this and you're trying to do trig. Okay, and say you have okay if theta is here, let's talk about the opposite adjacent hypotenuse. Well, the hypotenuse is always the hypotenuse, and how I know what the hypotenuse is, it's always across from the 90-degree angle. Okay, it's always across from the 90-degree angle. Now, the opposite, so the hypotenuse is going to be the hypotenuse regardless of where theta is, the angle being used. Okay, but now in this case, looking at this, the side across from the angle will always be the opposite side. The side that touches the angle that is not the hypotenuse is the adjacent side. Okay, so that the main thing is, guys, is knowing where your sides are. Okay, now now let's talk about it again. Now, if we have another right triangle, the side measurements really doesn't matter. But we're going to put theta in a different place. Okay, theta is always going to be one of your supplementary angles. complementary angles, one of these two. Now, let's say if theta is here, there's going to be some things that change. The only thing that won't change is your hypotenuse. Your hypotenuse is here. Okay, your hypotenuse is here. Now, in this example, the opposite side's here. But now, the opposite side is the side that does not touch the angle, the given angle. That's going to be the side opposite of your angle. That is the opposite side here. Okay, and then the adjacent side is the side that touches the angle. So, guys, notice that it's going on where your theta is. Your opposite adjacent is going to change. It's always in reference to theta, the missing or the angle given. It can be an angle given or a missing angle. It can be either. But whatever angle you're working with is going to determine what is your adjacent side and your opposite side. Remember, hypotenuse is always going to be the hypotenuse, regardless of where theta is. Okay. If you understand this, the other stuff it'll fall into place. Okay. If you don't understand it, shoot me an email. We may do a Zoom thing and get it maybe some more work with it. Okay. Now, so what I'm going to do, since you guys are going to be working on iExcel, instead of me printing out a separate worksheet, what I'm going to do is I'm just going to work on iExcel as well. Okay, so go to iExcel, click on that, and then we're going to go to my screen looks a little different than yours. I'm going to go down to geometry. That's where you're going to be working in this week. And let's go down to trigonometry. Remember, last thing you did was the right triangle stuff. Let's do one. Okay, now remember, one thing that you really have to remember is your side ratios. Guys, people has come up with different ways of remembering things about this. A lot of people just remember SOHCAHTOA. I'll show you that in a minute. You'll probably hear that more, that acronym used more than any of them. Okay. Now, so here's what your problem's going to look like. Okay. So remember, sine deals with opposite over hypotenuse. Cosine deals with adjacent over hypotenuse. And tangent deals with opposite over adjacent. Okay, you got to remember those three things. SOHCAHTOA. Okay, now, you may be able to come up with some other ways of remembering this. You will have to remember it, though, because more than likely there's no teacher going to let you have these notes on a test or something like that. Okay, now, let's look at this example right here. Okay, so iExcel number 1. All right, so we got triangle might not be the best triangle, but it's going to work. It'll work. And then that's that one. All right, it says this is 28. This is 53. And this is 45. This is and it says E tangent to C. Okay, so and you're got to write your letter D, C, E. Okay, now it says find the tangent of C. That's what it's saying right here. Find the tangent of C. Now, so here's C. So think about this being your theta. Okay, your missing angle. Now, so what you want to do is you're wanting to find what they're wanting to see is you can identify the sides that go along with tangent. Okay, so now remember tangent. So tan theta, or we're gonna put tan E here because it's tan E equals. Remember, it's opposite over adjacent. So we're gonna put our little division bar here. Okay, now opposite is the side that is the side that's across from you. Okay, so that's going to be 45 and then the adjacent side is 28. Okay. Now, now it says to simplify the answer. So what I'm going to do is I'm going to take my calculator, put in 45 over 28, 45 over 28, press enter, math, enter. That will not reduce. Okay, so what I'm going to do here, tan of 45 is 45 over 28. All right. All right, now it wants the tangent of E. Okay, so let me give me another sheet of paper. Guys, it wouldn't hurt for you guys to go ahead and write these down. Okay, keep them with you while you're doing this section. Okay, find the tangent of E. Okay, so now this is IXL number 2. All right, so now that's going to be all right. All right, now so that's 12, 35, 37. Okay, here's my right angle. Okay, so it wants the tangent of E. First of all, you need to identify where E is. D, E, F. Here's E. Okay, so that's the theta here. Okay. Now, once again, it's tangent. Now, you remember tangent, the tan of E is opposite over adjacent. Okay. So now, so if E's here, the opposite side is going to be 35. Okay. So the opposite side is 35 from here, opposite side. Now remember, guys, this is the hypotenuse. Tangent does not deal with the hypotenuse, so you will not have an hypotenuse measurement here. The adjacent side is the side that touches the angle that is not the hypotenuse, which is this guy right here. Okay. All right. Now, there's your ratio. Now, put it in your calculator, see if it'll divide, see if it'll reduce. 35 over 12. Math, enter. 35 over 12. That will not reduce. So we're going to do 35 over 12. All right. The cosine of y number 3. All right, so we got this, this. Okay. X, Y, Z. No, X, Y, W. Okay, now 20, 48, yeah, and 52. Now it's wanting to find the cosine of y. Okay. Now here's so this is actually going to be our theta here. Okay. Now it wants to know what the cosine is. Now remember, cosine of y equals adjacent over hypotenuse. Okay. Adjacent over hypotenuse. Now remember, the adjacent side is the side that's not that is touching the angle that is not the hypotenuse. So this side is touching the angle, but it's not the hypotenuse. So that being said, the cosine of y, the adjacent side is 20. Okay, this is the adjacent side in reference to y. Okay, now the hypotenuse is of course across the 90. This is this guy. Now, guys, I'm pretty sure this will reduce. So before you type that in, make sure you would, if this is your problem, make sure you would reduce it. So it's going to be 20 divided by 52. Press enter. Math. Enter. 5 over 13. So the cosine of y equals 5 over 13. Okay. So now you put in your there. 5/13. Okay. All right. Now the next one. IXL number 4. I'll probably get it to 80, then I'll let you guys work on yours. Now, so 4. Let's see. It looks like it's giving plenty of points here, so if you don't get many wrong, it shouldn't take long to do this. All right. Here's my right angle. D, C, B, 17, 8, 15. Okay. All right. And we're looking for the cosine of C. So this is going to be our theta here. Okay. So this is our adjacent side. This is our opposite side. Now, when I say that, that is in reference to theta, where it's at. And this is always the hypotenuse. Okay. Now, remember, cosine, well, in this case, it's C. The cosine of C is equal to, the cosine is always adjacent. Adjacent over hypotenuse. All right, now, so let's figure out what our adjacent side is. Well, our adjacent side is the side touching the angle that is not the hypotenuse. So that's going to be 8. That's good. Okay. And then the hypotenuse is 17. And guys, looking at this, 8/17, 8 is not a prime number, but 17 is a prime number. That will not reduce. So that's going to be your answer there, because that will not reduce. 8/17. There you go. All right. Let's do it. I feel like it's better for me to do the ones on IXL because it'd be more like the ones it shows you. Okay. Um. Okay. So we've got 2. Okay. That's 10. 26, 24. This is X, C, Y. Okay. Now this is IXL number 5. Okay. All right. So now, looking at this, guys, we need the tangent of Y. So first of all, identify what angle it is. So this is Y. So this is your theta. Okay. So tan of Y equals opposite over adjacent. Opposite over adjacent. Okay. All right. Now, so tan of Y equals opposite of that is 24. Because that's the opposite side, because it's the side not touching the angle. And then your adjacent is the side touching the angle that's not the hypotenuse. So we know the hypotenuse is here. It's going to have to be this. Okay. So if we reduce that, that's going to be, we're going to reduce that by a factor of 2. 12/5. And this is your answer. Okay. Let's put that in there. 12/5. There you go. Okay, that's what we got here. All right. Write your answer in simplified, rationalized form. Do not ram. Okay. So basically, on this one, guys, you're not going to be able to. You're going to have some radicals here. Might have to do a little bit of math to it. IXL number 6. So it looks like to me once you get around 68 points or in that region, you may start seeing some stuff that's a little more intuitive. So here we go. We want to look at this guy. All right, so 2 square root of 5, 2 square root of 7, and we don't know what that is. Okay, so now you're going to have to solve a little bit here. Okay, so what we're going to do, the tangent of I, so I, H, J. Now, guys, here's a problem. Well, here's something a little different. Tangent of I equals, now, tan is opposite over adjacent, right? So tan of I is opposite over adjacent. The only problem is, here's our theta. Here's our theta. The only problem is we don't have an opposite. Okay, so this is missing. So you're going to have to, I'm going to identify that as x. Okay, so I'm going to put x divided by, what's up, baby? All right. Now, so what we got to do, we got to figure out what our opposite is. Okay, so now, okay, so now here we go. Now it's opposite over adjacent, so 2 square root of 5. Okay, so now, so what we're going to do here, guys, we got to figure out what x is. Okay, so what we're going to do, we're going to do a little bit of math. Okay, now let's do this. We're going to get x by itself. So first of all, we're going to do times both sides by 2 square root of 5. Okay, now, and then this will cancel out. And guys, the reason we're doing this, we need to get x by itself. Okay, so what that's going to be is 2 square root of 5. Okay, now, wait a minute. I'm getting ahead of myself. Now, on this side, okay, so that's right. So 2 square root of 5 times tan of I equals x. Okay, now, to get, okay, so, let's see here. Oh no, guys, I went the wrong way with this. Hold on a second. I went with the let's back up just a minute. Let's get that side by using Pythagorean theorem first. That's what we're going to do. We got too many missing sides here because we don't have an angle either. So so here's what we're going to do. All right, we're going to do Pythagorean theorem. Okay, so now let this be x. So it's going to be x squared plus 2 square root of 5 squared equals 2 square root of 7 squared. Okay, let's do it this way since we just need the side. Okay. Now that's going to be x squared plus 4. Square that. Now if I square that, that gives me 4. If I square this, that just takes the square root away. Equals, now 2 squared is 4, and the square root of 7. Remember, this is being multiplied. Square root of 7 squared is just 7. It just takes the square root away. So what I got is x squared plus 20 equals 28. Okay. Now, subtract 20, and that's going to give me x squared. This cancels, equals 8. All right, now take the square root of both sides to get the square. I need the x by itself, not this x squared. All right, so now that's going to be x equals the square root of 8. Now what we need to do is break this down. Okay, so it's 2 and 4, 2 and 2. All right. Now, so what we got here, we have a pair of 2's. Okay. That goes on the outside. This 2 will go on the outside. So I'll write it up here. The two left over is needs to go back on the inside. Okay. So now we have our x. Okay. Now we have our x. So now we can go ahead and now do our tan. Find our tan of I. So tan of I equals opposite over adjacent, which is 2 square root of 5. Okay. Now, let's go ahead and get our rationalized denominator here. So that's going to be, to do that, we're going to take the square root of 5. Now, guys, what I'm doing here, I'm rationalizing my denominator. Okay, so what that means is I'm getting this square root out of the denominator. So how you do that is you take the square root of 5. That's the square root of the denominator, which can't be there. You're going to multiply top and bottom by that. So what that becomes is 2 square root of 10 over 2 square root of 25. Okay, but now what's going to happen here is the square root of 25. You should know that by now is not a perfect square. So the square root of 25 is 5. Okay, so what that's going to be is this 2 square root of 10 over. Now, guys, we no longer need the square root of 25 because we know that's 5. That's 5, right? So now that's going to be 2 square root of 10 over 10, which that will reduce to square root of 10 over 5. If you reduce this down, 2/10 reduces to 1/5. Okay, that's where this came in. This is your answer right here. Okay, guys, that's a tough problem. I mean, you gotta know. There's a lot of stuff to know there. Okay, I'm gonna let you guys get to 80 on this, and then that way we can. Guys, this one is actually a special right triangle. Notice right here, the hypotenuse is here. Okay, notice that these are the same two measurements. Okay, so now if you do the tan of u, okay, so I'm going to show you how to do it, but this is a really easy question. If you knew how to if you knew your trig and stuff really well, you could answer this really fast. Okay, so if I have this, all right, this is 10. This is 10 squared root of 70. Okay, and then we got that. Okay, now, so here's my u here. So that's theta, because it says the tan of u here. That's where I got that from. Tan of u. Okay. Now, tan of u equals 10 square root of 35 opposite over adjacent, which is 10 square root of 35. Now, guys, think about this. If you've got anything where you got the same something over itself, that's always going to equal to 1. Okay, so the tan of u is just equal to 1. That's actually a very easy question if you understand trig. All right, guys. I'm gonna let you guys. If you have any questions, let me know on Google Classroom. And what I'll do, I'm thinking about maybe doing a Zoom meeting or something like that to help you guys out a little bit. If you or you can take a picture of it and let me see it over email, and I can kind of walk you through it. But guys, this is section R1. I'm gonna put it on Google Classroom for you to work on. Matter of fact, I'll do that now. But if you have any questions, let me know. Mr. Robinson will be available to help too. So just let us know. Go ahead and get started on this. Well, I guess that's it for today. So have a good day.